Yeah, I'm extremely sorry, everyone. I did not realize the screen was not visible. So to start with, we were at the first slide. This is the introduction, and then yeah. So these were the topics. Let's start from the objectives again. So as I told you, our objective is to review and demonstrate Windchill ERP integration. The introduction, we will go with the introduction of boundary systems, PDSVISION, and then we'll go to the topic overview and the demonstration of our topic. And next, my name is Radhika Bhagat. I am 7+ years of experience in PTC Windchill products, and I am also a certified Windchill implementer. So we are PDSVISION, formerly known as Boundary System, and we are technology leaders in PTC global resellers, and we are the first PTC global reseller and preferred services provider. And we also develop solutions for design and manufacturing. Next is that we have capabilities in consulting, implementation services, professional training, cloud, and help desk. And if you see the graph below, it gives us an idea of Boundary Systems, which was founded in 2006, and it was then acquired by PDSVISION in 2018. So these are some of the partners. It's PTC, Tecton, Moldex 3D, Xformation, Etraj, Sigma 6, ZWCAD, Keyshot, ITI, Symmetrics. And let's come to the main topic. We have three main topic overview today. We will start with why need to integrate Windchill with ERP. The next is how we will be integrating that. I mean, what are the factors that needs to be considered before approaching the integration? And the third is what are different technologies involved to integrate Windchill with an ERP system. So let's discuss about the market pressures right now. As I told before, we have market pressures in having quicker time to market, which has because of which we need to have a shorter development cycle. Then we have to manage the increased product variability and the complexity. Next is we need to manage and operate in globalized supply chain. Another thing is that we need to improve our operational efficiency and excellence, and at the same time meet the cost targets. And the pain points or the challenges that we face through are the disconnected engineering and manufacturing teams. We have difficulty to find and reuse proven manufacturing processes. We are also struggling to provide accurate manufacturing information to the production on time. Again, we have a lot of manual processes and tools and disconnected legacy system. So due to this, it results in inefficiencies and higher cost of production. Again, due to the manual processes, we have delays and we also have errors in the process. So what could be the solution on this and how companies can address these challenges? We can integrate the upstream system, that is the PLM, with the downstream system, that is the ERP. Let's see another reason why this is supposed to be done. So PLM and ERP, if you see at the picture, they both serve a different purpose. PLM system serves as is taking care of more of the designing phase, or it takes care of the requirements capturing, it takes care of the manufacturing process management also. And ERP on the other side is taking care of the physical production and also sales and finance and sourcing. So we don't have a single system which is doing each and everything inside it, each and every process and data in this. And hence we also hence this observes the need to integrate these two systems. Another interesting thing is that depending on some of the surveys done for the industries over the world, it has been observed that the best-in-class companies, the researchers found that they were the 40% more likely to have integrated their PLM system with their ERP system. And another interesting thing there is another interesting thing that was observed in the research, that the PLM to ERP integration was the most common integration as compared to any other integration which is being done for any organization. So PLM and ERP integration was the most preferred and the common one. Yeah. Another good impact of having these two systems integrated is the higher quality of the product, because it improves the design decision making, and it also reduces the errors. The second point is reduced cost, because the errors are reduced, we reduce the scrap. We also we also reduce the time spent on synchronizing the different systems, and the reduced cost of creating and maintaining custom integration software is done by almost 50%. So the third important thing is that shorter time to market, because the things are integrated and there is also automation and reducing number of data errors. The cycle time is reduced up to 40%, and hence we have a shorter time to market. So let's look at the relative position of PLM and ERP over the time period. If you see on the left hand side, it shows about the old ERP and PLM system, how they were in yesterday, how they were during the old times, and on the right side it will show us an idea of how the systems have evolved over a period of time. So on the left hand side, the focus was more on the manufacturing optimization. So ERP was served as the most focused system, and it was related to other systems such as PLM, CRM, etc. However, today both these systems such as PLM and ERP have evolved in such a way they have more and more capability, and such as PLM has quality innovation strategy in it, and ERP at the same time has also evolved and added more capabilities such as logistics and finance and HR. So now the focus is not just on manufacturing optimization, but it is also on the product innovation and excellence. So now let's have a comparison of what is PLM and ERP. So PLM is taking care of the intellectual assets. It has EBOM data in it, it has MCAD, it has CAD data, it has software parts in it. Also, in organizations where we are maintaining the manufacturing data, their PLM has MBOM, process plan, resources, and it also has the quality compliance, service BOM, and other related features in it. On the other hand, when it comes to ERP, it is more focused on the physical product and the physical assets. So it is more concerned on the physical data, physical product, in terms of tracking inventory. It is also handling in terms of handling material, in terms of quality check, in terms of manufacturing schedule, the routings, all such activities which are being performed on the manufacturing shop floor. So As you can see, PLM serves in defining the life cycle of the product. However, ERP serves into the production of the particular product itself. And now we can see what could be the impact of integrating these two assets. So if we have an integration between PLM and ERP, it will help in reducing the production cost. So PLM, the decisions related to the cost. So 80% of the decisions related to most of the product are being done in the PLM itself. And hence, decisions made over here can impact up to 80% of the product. However, decisions made on the ERP side can impact up to 20%, up to about only 20% of the product, because it's actually dealing with the physical product itself. And hence, for example, when it comes to changing the product, for example, if we want to change something inside the product, the cost will be quite less in the PLM phase as compared to its cost, which will be 10 times or 100 times higher in the ERP phase, because the product will be already generated, it will be already in a physical state, and hence changing that product will give lot of it will be having a lot of cost to it as compared to the PLM. So that is the impact of the production cost. Now, the next topic is that we will be seeing how to approach the integration between Windchill and ERP. So how to approach, meaning what are the things that we need to consider during the requirements phase. Let's start with them one by one. So best practice to elicit integration requirements. In the integration requirements phase, there are 5 steps. First one starts with system identification. Now here we identify whether what all systems are involved in our process. So whether the system is PLM system, ERP system, whether we have our PLM system integrated with only one ERP system, or whether it is integrated with multiple ERP systems. Another thing is the next step will be triggering events. So triggering events is where we need to define as to at which point we are going to trigger the transfer of a data from PLM to ERP. For example, at what time and for example, by which role we will be performing this action. So this could be, for example, in Windchill, we can trigger based on a set state of a part. For example, a part when it goes to a release state, that will be a time when a particular business needs to send its part to the ERP system. So those are the triggering events which we will be considering in the step 2. In the third step, we need to consider about the data elements. Now, when it comes to data elements, what are the objects that we will be considering when we will be integrating both the systems? Say, for example, from PLM side, what are the objects that we need to consider for integration, whether it is only parts or whether we are also sending documents along with parts. So that depends. This is the phase where we are deciding on it. On the other end, the fourth step is for mapping table. Now, here the mapping happens between the object from PLM side and the object from ERP side. So we can, in PLM for a part, in Windchill, we can say that a part is being represented as a WT part. However, in ERP, it could be represented as some item from their side or any other object that they have specific to their ERP system. So during the mapping tables, we will consider the relations between these similar objects. And the last step is persist data from one system to another. That means this is the actual transfer of data from one system to the other. wherein the data will be properly transferred in an accurate way, and it will stay in and it will be recorded properly in the system of record, as in the target system in the ERP system. So this picture gives us an idea of how the mapping of different objects can be done, how the relationship can be performed between two systems when we have an integration solution in place. So in Windchill, we may consider to send the change notice from PLM side. On ERP side, this can be recorded as a change master. Similarly, for a part, it can be recorded as a material or an item. Another thing is that a document can be considered as a document itself, but when it comes to EBOM and MBOM, maybe in ERPs, in some cases, they don't have a view specific BOM, so we only have one BOM. In another case, companies which are using MPM link also when it comes to Windchill, they can also send their MPM link data such as the MBOM. For example, we can also send the process plan, the operations, the tooling, material, and other resources specific to a BOM to the ERP system. So this gives us an idea. So the data flow depends on our scope as to what we decide on which objects are supposed to be transferred. The next question will remain as who is the master when it comes to sharing the data. Now we have decided on sharing the objects. We have decided on when we share the objects, we need to decide on what attributes need to be shared between these objects. And in some cases, it may happen that an attribute such as a part number is unique to Windchill. So that part number should be updated only from Windchill side. So this is the phase wherein we decide which is system, which will be the mastered attribute, which will be the mastered attribute. For example, in our case, in this example, if we say that the part number is unique in Windchill and should be updated only from Windchill side, so it will be a PLM mastered attribute. So the business objects extended throughout the enterprise, and in this way attributes can be shared across systems or unique to a particular system. So updates should only override attribute that a system masters in this case. So the picture just gives an idea of out of all the attributes in the enterprise solution, we have some of them which will be specific to PLM, or some will be specific to ERP only. Okay, now up till now we have seen the approaches of how we should start with the requirements gathering and how we should decide on the Windchill objects, what are to be sent and which system is mastered. So the next step is when we are implementing this, what options are available for us to integrate a Windchill with an ERP system. So we have three main options when it comes to the technology options. The first one is the Java API. Now, as we all know, Windchill is based on Windchill is a Java application, and hence a Java API option is where we will be using Java APIs extensively to integrate Windchill with any kind of system, not just ERP, but with other type of systems also. The next is web services. Using web services, when we say of using web services, we are using the info engine server of Windchill along with the ESI open APIs too. So Windchill info engine server is part of the method server, which gives us different capabilities to integrate the Windchill data. So web service will be using info engine and ESI open API. And the third option is the pre-built out-of-the-box integrations. Now, the pre-built, as in these are the tools already configured by PTC, and we need to install them and use them. We don't need more customizations around them. And one of them is ERP Connector, and the second one is Windchill ESI. Now, Windchill ESI as a whole is a complete module of PTC Windchill. And ERP Connector is a part of ESI. We will discuss more in detail on each of these options one by one. So let's start with the Java APIs. Now, these Java APIs are directly will connect with Windchill DB and give us the data and help also manipulate the data. But the important point to note over here is this approach is strongly discouraged by PTC because it's full extremely fine grained access to Windchill. But if we need a lot of understanding of Windchill data also at that Windchill API also at that time, and there are some benefits such as cost effective maybe, but there are also shortcomings such as it could be very time consuming to implement that, and also it's a tighter coupling. So whenever it comes to maintenance or whenever we have new releases, then the APIs, for example, an API can get deprecated and so on. So there's a lot of effort put in to maintain the same thing. Also, we need high level of application API knowledge at the same time to implement this. The next one is Info Engine. Info Engine is Windchill. It is part of Windchill method server, and it makes use of Windchill ESI services. So this is built into the Windchill server, and it is a standards-based integration. Also, it is interoperable with popular middleware solutions such as TIBCO and WebSphere, sorry. So Info Engine can communicate with TIBCO, which comes along with the Windchill ESI package. However, it can also communicate with other middleware apart from TIBCO. Another benefit will be very high flexibility. It allows the integration of any kind of system, as we said, not just TIBCO, it can communicate with other system also. However, the shortcomings are that we need customization. With the developing integration may be very costly also and time consuming. Also, it needs custom development, and again, it results in higher cost of update and maintenance over here. So this was a Windchill Info Engine server. So on top of it, we have the next layer, that means the pre-built, pre-configured Windchill tools, namely the ERP connector. And on top of ERP connector, we have the ESI. So let's discuss about the ERP connector first. This ERP connector will make use of all the layers below, such as the Windchill ESI, Open API, and will give us an export of the information of Windchill at that moment. So ERP connector basically gives us an export in the form of an XML file. So this ERP connector is unidirectional. So it's a pre-built business logic for integration. However, it's unidirectional, and it is not directly connected to any ERP system. But we do have tracking, we do have monitoring capabilities to it. There is full traceability of changes to the release data. Also, when it comes to tracking, we can monitor what data is released and what is the status of each and every transaction or sub-transaction inside this. So it actually releases data to a particular file. So that file could be an XML file. That file is an XML file. And this file is later supposed to be imported in other ERP system, because ERP connector stops there. It's not directly then after later on connected to any ERP system, and hence the shortcoming is that sometimes we need to customize it to have a return status. For example, we may need to have customization to have a return status from any ERP system, or we may need to have any custom development on the ERP side, wherein they will be able to import this XML file in their system accepted format. So that is another customization that may be required for using this. So, and also the architecture is not very efficient when the number of targets is high. Another that's another shortcoming for ERP connector. So let's go to the last option, which is the Windchill ESI tool itself. Now this is a pre-built integration to SAP or Oracle manufacturing ERP system. So Windchill ESI makes use of ERP connector along with a TIPCO adapter, which could be for SAP or Oracle. And it's a closed loop management. That means it is unidirectional. It is bidirectional. Sorry, it is. You can have a status message back, for example, in this type of integration. Then we have another benefit, which is built-in integration logic. Means we have less customization and lower ongoing maintenance. Since we are using the pre-built tool itself, we don't need to customize much around this. Another thing is highly flexible GUI development environment, means customizations and complex data mapping are easier here. And availability of additional adapters from TIPCO to support other enterprise integrations also. The shortcoming of Windchill ESI is mostly the ESI licenses. They are very high, especially for small manufacturing businesses. Most of the small manufacturing businesses would most of the time prefer ERP connectors when it comes to the if they find the licenses for Windchill ESI too much. Also, the licenses may be not competitive with ERP connector based solutions when the number of users is less than 100. So these are some of the shortcomings of Windchill ESI. In this way, we discussed about all the layers that will connect and ERP system to the Windchill database in depending on their technology. So I think we can now start with a small demonstration, and this demonstration will be about ERP connector. So let me start showing my system. So as you can see, I am on Windchill homepage. Let's try to go to one of the part inside Windchill. So I've already created some data for this webinar. We have a part here, a simple part. For this demo, what I can do is, what I will be doing is, I have a part, and then I have a document associated with that. Is the describe by document, and we will try to send this part to and generate an export of this release. So this will be one release example, and then in the next example I can show you a demo of how we can export an EBOM and its associated CAD documents also. So let's start with the part. Now whenever we want to release or publish a data from PLM to ERP system, it can be done in three ways. PTC Windchill gives us three options, starting with one, which will be a set state. That means if a part goes and reaches the release state or any other state depending on our requirement, we Windchill ESI can publish the trigger. Next is the next option is a manual, which is from the actions menu. We can have the option to manually send to distribution target. So we have this option which says send to distribution target. This will help us to send data manually to the ERP system. And the third option is through the change notice, which will be an automated process. So we'll go with the first and third option today. What I will be doing is I will do a set state on this part, and which will trigger Windchill ESI, and it will generate an export of this data to an XML file. That is what ERP Connector will do. And to see the status of how this is going, we have to monitor it on the table which says distribution target over here. So right now we don't have anything. What I will do is now let's go and do a set state. I will also go to Windchill utilities where I will show you how we can create the distribution targets, and also the place where we can monitor the transactions every day. Let's go back to the distribution target table. So this table shows to which manufacturing plant we have sent this data. If I go to actions today, and you can also associate manufacturing plant to this data. Say for example, I click, you have an option over here which says associate distribution targets. If you click on this, you will get to see all the distribution targets present inside the system. Okay, for now, for our demo today, I have a distribution target meaning PDS plant 1. So in terms of Windchill ESI, a manufacturing plant is called as a distribution target, right? And hence, if I have this default as yes for a particular context, that means for this organization, whatever parts will be published or triggered, they will always go to this default distribution target. For example, for organizations where one particular organization is using only one manufacturing plant, this can be set as a default for context. But however, in some of the manufacturing companies where we have multiple targets, we can select all of these, and if you click on OK, you will come to know that we will be able to assign multiple plants or distribution target to that particular part. And so when I send this part, it will be sent to all these three. But for today's demo, I will remove these. We can also go over here, and there is an option to remove. Yeah. So let's see. I think it must have removed everyone. No. Yeah. Let me remove this one also, because this is default for context. We don't need to exceptionally go and associate them manually. Now let's go to the actions, and I will do a set state. As I told you, the first option is where once everything is once we do a set state to everything, the objects will start, the publishing will start for those objects. So let's collect the document related to this part. It's released, and I do a set state. Now when I do usually this set state happen through a change notice, but for the demo I'm just doing it manually. So if I do manually set state and I click on OK, we can see, let me show this. We can see the status over here, which says in the distribution target table, you will get to know that a publishing status has appeared over here. This publishing status shows whether our transaction, that means one transaction means that at that moment, whatever part or a set of part you are sending to the ERP system, that is called a transaction. So if you click on the succeeded message over here, you will get to know what all objects are being transferred. So we had one part and we had one document. Now let's go to the location where we have, yeah, this is a location where the ERP connector will export our data. So if I open these, you will come to know that Yes, so this is how ERP connector will export our data. That means in an XML format, and each and every data it comes under the respective XML tags. For example, a document will come under a document tab. For example, this is the manual document that we assigned, and it comes under this document tab. Similarly, we can also have part in it. So I think it's not in this file. It depends on Windchill ESI. It can also publish it in other files. So if you see the same transaction, we have part which came inside the part tag. So you will get to see the object ID over here, which is WT part. You will see the number, part number over here, the name of that particular part, the state at which it was sent. So since we did a set state to release, it was sent on the release date. We also got to see the design, the view, whether it is design or manufacturing, and some other attributes. And it can also be configured to add the new IBA attributes inside this. So this is how the ERP connector will export the data to this XML file. Now, when it comes to integrating, any other ERP system can take this file and manually import it, or they can also have a shell script running on their system wherein they can change this XML file to say maybe CSV file, which will be a more readable format, and they can import it. So it depends on our way of handling this. I can close this now. If I go back to the part, now this is where we have transferred the data and we have a success message. We also have another place inside Windchill where we can monitor each and every transactions, say for example on a daily basis or on a weekly basis. If we go to browse site utilities, inside this we have an option which says enterprise systems transaction administration. This is it. So this option is available basically only to the ESI administrator. Now ESI administrator is a role inside Windchill which comes into Windchill ESI module, and only that role has access to this monitoring and tracking. So let's search for all the transactions that happened today. If I choose a date range over here, say for example today, and I click on search, we will get to see what all objects were released today. The latest one was the one with part and a document. So if we expand this, we will get to know that these two, yeah, we will get to know that there was a document and a part that we sent. So there was one manual doc, and this is demo ERP release, which was the part that we sent. Also, we have the transaction that has happened over a period of time. That is what all transactions happened today on the 10th of August can be seen over here. Or even you can search by filtering out with failed transaction or pending transaction. Now, these are other status that can come onto the transaction. A failed transaction is that it must have failed due to some ESI errors. Pending means that it is still in progress, and succeed processes again, it's still processing. And then succeeded is when the transaction is completely 100% sure, accurately done, and then we have a success message. So that is how we can monitor the data. Another thing I wanted to show is the place where we can manage the distribution target. That means the manufacturing plant, as I said. So we can again go to this site utilities, and we have an option to manage distributions. Go down. Yeah, manage distributions. I have created a couple of test distribution targets over here, but you can go over here. We have a create distribution target option, and there are different formats available to create that. For example, the one that we use right now, the XML, is this file type. But apart from that, we also have other options for the Oracle applications, the SAP, and then we have the FTP and email options also. And also we can also have a custom one included here also. So this is how we create them. And these two are an example of how we have created two more in FTP. Another thing, coming back to the, let's go and see the properties for each transaction. So for this transaction, let me try and edit and show you for this target, sorry. Now this is the page where we are configuring a distribution target. So you give the names, give the place where we want to have the export of the file, and then when you click on next, we have the configuration options which will define our data in which form it will be exported. So there are options such as which will help us to set whether we need to publish part, we need to publish alternate part when publishing part, yes or no. Then in terms of, there are some settings related to BOM settings. For example, if we can have a filter for a particular BOM over here, which will help to have, for example, help us to have all the child items in release, then only you release it, otherwise it will give an error. So these are some sort of filters which we can apply to a BOM. Again, there are other properties that can be applied. We can apply what number of levels in a BOM can be sent. Also we can apply whether there are other MPM link data such as process plan. This is about change notice setting. So here we can again set up a filter for publishing a change notice. Then we have other related attributes again specific to the change notice. For example, publish part associated process plan when publishing a change notice, yes or no. So similarly, we can have settings for process plan, and because we can export process plan also with ERP connector. Okay, so that's why we can have settings for that also. And again, we also have settings for resources and CAD documents. Now coming down to the main point is the general parameters. Now this is a ESI response meta info file wherein we can set up a format of what all attributes can be defined and can be exported. And this is the main file where we set up the number of attributes and what all attributes we want to send, say for a part or a BOM component or a header or a change notice. So this is the path of that file. So these are some of the settings included in the distribution target. Now going back to our demo, we were discussing about, we sent a part and AWT document, correct? And if you go to the related objects target over here, you get to see that it is succeeded. Now when you try to publish this part once again, ESI will give you an error saying that this is already published and you cannot send it again. So if you try to send to distribution target once again, okay, and you click on that and you click on next, you will have a message over here. If I click on this triangle, you will get to see inside the message which says that the part has not been changed since it was last successfully published. Okay, so this error means that whenever we are trying to publish anything to ERP system, that should always be a new revision. Since we just sent the part inside since we sent that part with 8.1 revision and it is right now successfully sent, Windchill ESI knows that the part is already present in the ERP system. Okay, and that is why it currently gave us an error that A version is already present. So what you have to do now is go into actions and revise it. So if I go in actions and revise it, we have a new version, new changes coming up, which the ERP system is not aware of. And that is why when I click on revise, let me collect the document, for example, and if I revise both of them, I click OK. And after revising, if now I try to send them, you will come to know that the error will not come. So if I go over here, click on send to distribution target, click on next. You will get to see that the objects have come. That means the error is gone. That means there are new changes coming up to be new changes going to the ERP system, and the XML file will come to know about these changes based on these actions. If you see the actions over here, what it is trying to do is, because we changed the part from A to B version, it is giving the action as changed. Again, because we changed the document from A to B version, it is giving the action as changed. The next one is deleting. Now this described by link is from version to version. That is why the link with A version was deleted, and we are creating a link with B version. So this is just an indication of that the link is changed. So even before sending the data to ERP system, we can have a preview of what is being sent over here. So this UI gives us an idea of what we are trying to send to the ERP system, and also you can have a preview of that XML export in this option which says raw data. If you click on this, you will come to know what ERP export could have been generated if we had clicked on finish. So this is what we were trying to send. We were trying to send the part in B version. If you see, the version over here is B, correct? And it came as changed parts. So these are some of the terms through which the ESI will come to know that if there is something changed, if there is something added, if there is something deleted. So this is how the XML can imply the change or deletion of any object or any link inside the system. So this was that, and okay. Yeah, and the last option inside the demo is I can try go to the part over here. Now we have a structure. We have a simple worm over here, and it is having owner. It is having its CAD associated with that. Now let's collect them all. This is the third option we are going through. Third option means through the change notice, which will be an automated publish of all the parts in it. So let's copy this part. I will quickly add this because we don't have much time. I will quickly add this inside the change notice. Let's demo. Next. Let's collect everything. So ERP gives us a functionality to even publish the CAD objects, the WT documents, and also the NPM link data such as the process plan, the resources, and all. So I just created immediately. I'll just create a change notice, and if you go to the implementation, I will quickly complete this task. And if I go and refresh this, we have a review task. In the review task, if you go and see the resulting objects, we have added all the CAD and the WT part in it. So I'll go to the task and complete this. Next is, let's refresh. Yeah. Now once I complete the audit change notice task, the objects will not just be published and sent to ERP, but they will also be set state to release. So once it is complete, let me see if the CN is resolved. Yeah, and I can go to the objects. If I go to the assembly, you will get to see that it is released. Also, all the CAD and child components associated with them are also released. And let's quickly have a look at the distribution target table, you will get to see that it is succeeded. And if I open the export of this, so just refresh, and if we open the ERP connector export of that, you will get to see that this time we have an ECN header because we sent this data through the change notice object type. Below that, we'll also get to know what all parts are added inside the system. So whenever we publish a assembly, the parts are first sent one by one, and after that, the usage link information such as which part is a BOM component and which part is a BOM header is being sent. So if you go and see here, 389 was our parent part, and that is why it came under BOM header. Also, this BOM header has had 3 child components, correct? And so if we go below, we'll get to know that the number of BOM components are the part number 390, which ends with 390. This one has the same assembly number. Similarly, there is another BOM component in that assembly, and this should be the third one. So that. Okay, the third must be unchanged one. That's why it did not come. Mention that. So this is an example of BOM transfer. Yeah, BOM header. If you go back to the system, second, let me refresh. Yeah, the success message, you will get to see what all things were created for that particular BOM, for that particular assembly. So this is how a simple BOM can be published to the ERP system. Okay, there's some issue with the view of the system, but yeah, this is the end of our demo, and let's get back to the presentation. We are right now done with our demo and our webinar. So if there are any questions right now, anyone have any question, I will give a couple of minutes to go through them. So I